we're looking at properties of graphs. Now, we talked about this idea of graphing being really a good idea, the idea being that, well, as we say, a picture is worth 1,000 words, a graph is worth 1,000 word pairs. And we want to use a graph to identify different behaviors or trends in the, the data that we're looking at. So let's take a look here. First off, we're going to look at increasing, decreasing, and constant places in functions. So increasing, decreasing, and constant. So first off, for increasing, f of x is increasing on open interval I if for x1, x2 in I, and x1 less than x2. So x1 and x2 are in this interval, and one's smaller than the other. Well, we have f of x1 is less than f of x2. So f of x is increasing on open interval I if for x1 and x2 in that interval I, where one is smaller than the other, then f of x1 will be less than f of x2. Let me draw a picture. So let's say we have our portion of the Cartesian plane, and here's our interval I. Pick a couple points, x1, x2. Well, here we have x1 less than x2. And think about the number line. Smaller numbers on the left, bigger on the right. Now, if f of x is increasing, it's doing something like this. And if it's doing that, here's f of x1, here's f of x2. So this means f of x1 is going to be smaller than f of x2. So that gives us this. So when we talk about increasing and decreasing, we're looking at the function from left to right. So as we move left to right, is this function rising? If it is, that means it's increasing. What about decreasing? F of x is decreasing if x1, x2 open interval I, x1 is less than x2, what we'll get is f of x1 is greater than f of x2. So what does this mean? Well, here's your I. Let's say x1's here and x2's here. Again, x1's to the left of x2. Well, a decreasing function is doing something like this. And so here's f of x1, here's f of x2. And so what we'll get, f of x1 is higher f of x2. And again, when we think about decreasing, we're looking as f of x drops going from left to right. So that's decreasing. How about constant? Excuse me for that. F of x is constant if x1, x2, in open interval I x1 less than x2, but yeah, that'll work. X1 less than x2. We have f of x1 equals f of x2. So what this looks like. A constant function doesn't change its value. So I'm going to try to draw a flat line here. So f of x1, f of x2. So once again, x1 is less than x2, and this is our interval I. And here we have f of x1 and f of x2 are the same. So that's what it means to have f of x as constant over an interval I. All right. So that's increasing, decreasing, and constant. Now, another feature you'll run into is what we call relative max and relative min. So for relative max, relative min, f of x has a relative max at x equals a in open interval I. If for any other x in I, f of x is less than f of a. So typically where this occurs is where you have a peak over interval I. So let's say we have our interval I, and we have some kind of a peak over this interval. and this occurs at x equals a, well then the point at the top of this peak will be a f of a. And then the value here is f of a. And so this is going to be the relative max. And notice if you choose any x anywhere in this interval, that f of x is less than f of a. So that's the idea of a relative max. All right. So f of x has a relative min at x equals b in open interval I if for any other x in I, we have f of x is greater than f of b. So a picture of what's going on here. So here's our open interval. And let's say our function's doing this. So what this basically says is that our function has a trough somewhere over, or it could be under, this interval. So here's the bottom of that trough. And this occurs at x is b. So the point b f of b, that's going to be a relative min. And then the value down here is f of b. And let's choose an x. Well, choose an x in this interval. Here's f of x. And notice that f of x is higher than f of b. So we get f of x is greater than f of b. So that's the idea of a relative min. Now, let's take a look how you might apply this in an example. Pull up a problem here. So let's say we have something like this. Let's say we have this function contacts the x-axis at x equals 3. Well, let's say it contacts the x-axis, x is -3. So where is this function increasing? In fact, let me make one little change here. Say it's doing this. So where is it increasing? Well, it's dropping down here again. We talk about increasing and decreasing as we go left to right. So it's increasing, well, here it's decreasing, but here it starts increasing. So it's going to be increasing. And again, we're using open intervals. That means we're going to use parenthesis -3, and then it stops increasing near 0. And again, we're using open intervals. That's how we defined increasing, decreasing, constant. We ask, what's this function doing over an open interval? Well, now it starts decreasing again. But then it starts increasing at 3 up to x is 4. We have 3, 4. So that's where this function's increasing. And the idea of doing this, again, you could have this spreadsheet with hundreds of points, and you could be scanning them and scanning them. Okay, what's happening with the x input and the y output? Or if you can graph it, well, there you go. You can just read it off really quickly. That might save some time. What about decreasing? Well, where this is decreasing, here, let me get a different pen. As we look at the graph sweeping across left to right, when is this thing dropping down? Well, it's dropping down here. This arrow means it keeps rising up and rising up. So as you sweep across this graph, you'll encounter the graph, say, up here and watch it drop. Or you might get it up here and watch it drop. But no matter how far you start out in this direction, once you turn around and go from left to right, out here, this is always dropping down. So that means it's always decreasing coming in from the side. Again, if you're going left to right. So that means -infinity, -3. But then it starts increasing. But then it decreases again. Then it stops. So it looks like it's decreasing from 0 to 3. Union 0 to 3. And again, we're using open intervals because that's how we defined increasing, decreasing, constant. Now what about constant? Well, again, we're looking for an open interval where this is constant. For increasing, we were looking for an open interval or union of open intervals where this is increasing, this function. For decreasing, we're looking for an open interval or union of open intervals where the function's decreasing. For constant, we're looking for an open interval where the function's constant. Let me see if I have another pen in here. I don't think I do. So I'll have to do this. This will be constant. It appears that it's constant starting at 4, but it's going to be constant forever. So 4 infinity. So now we have an idea of where it's increasing, where it's decreasing, where it's constant. Now, what about, say, our relative max or relative min? Well, typically what we do is we can say we have a trough, we have a relative min. So in this area and in this area, we have a relative min. So we have -3 and 0 and 3 and 0. What about a relative max? Well, for a relative max, we want to look at a peak. And here we have a peak. Relative min, there's some point that's lower than all the surrounding points. And there's some point, again, lower than all the surrounding points. And here, we're looking for some point that's higher than all the surrounding points. So in this case, we have a local max at 0, 4. So these are the properties we're thinking about so far. There are going to be others, but for now we're looking at increasing, decreasing, and constant. What are open intervals where this function is increasing, decreasing, and constant? And then are there places where you have a relative minimum, some point that's lower than all the others, and again, on an open interval. And there's another point where it's lower than all the others on some open interval. So like, say, in this area, here. So those will give you relative minimums. And then is there a relative max, some point that's higher than all the others, again, on some open interval. And, well, that's what we got. So, any questions? Let me know.